Hey everyone, and welcome to our lesson on translating the graph of f of x equals x squared. You might hear this graph referred to as a parabola or a quadratic. They really mean the same thing, f of x equals x squared. And in order to understand these graphs and understand the translations and what's going to happen to them after that point, we need to go over a few terms that will be necessary throughout the lesson. So let's talk about those first. When you see certain forms of the equation, such as the vertex form, you're going to see that an h and a k is used, and what that's referring to is the x and the y location of the vertex. They don't use an x and a y because they don't want two x's and two y's in the same equation. It's really just to keep all of our pieces straight. Axis of symmetry is the next term, and that is going to be the center of our parabola. It's what it sounds like. It's the middle. Parabolas are symmetrical. They should be the same on one side as the other. There should be a point in the center where it's sort of a reflection of itself over that point or over that line. So that's called the axis of symmetry. So we'll talk about where to locate that. And then quadratics also have minimums and maximums, or one or the other. Depends on how they're opening. If you see that a parabola is opening upward, it will continue on forever in both directions where the arrows are, but it will reach a minimum point. If it's opening upward, it will have a lowest point that you can identify called the minimum. And if you see that your parabola or quadratic is opening downward, it should have a maximum point somewhere on that graph. That'll be at the top of the graph, wherever it reaches its max height and then continues to go back down. One thing about these 2 points, the minimum and the maximum, is that they should be located at the vertex. And another special thing about that place is that's where the axis of symmetry should always fall as well. Alright, going to talk about a couple more things. The domain. If you've never heard that term, domain, that means that we're looking for where the graph occurs in the x direction. So x direction is going to be our left to right direction. We just want to know what all x values does our picture cover. Okay, and with quadratics, you can think about the ones that are vertical, the ones that are going to be opening upward or downward. They're going to continue on both ends. So they're going to really continue on forever in each direction. So with our vertical parabolas, we can always say that the domain covers all real numbers. So from negative infinity to positive infinity, eventually our graph continues forever, so it's going to cover every number. The range, however, if you take a look at these same pictures, is going to be affected by where our quadratic is moved on the graph. Range is our y direction. It's our up and down direction. So we can see that as we slide these, as we translate them vertically up or down, it's going to affect what all y values are covered by our picture. Okay, so we're going to see an example of that in just a second. Intervals of increase and decrease are going to come up when you start talking about quadratics, and that is simply where the picture is moving down and where the picture is moving up. You want to read the quadratic like you would read a book from left to right. So from left to right, you would picture traveling along the quadratic, and you would think about where's your hand moving down and then where is it moving up. There should be one interval of each, since there's always going to be a place of direction change on our quadratic, and that may be at a minimum or a maximum. So let's take a look. The parent graph, f of x equals x squared with no translations, is located right at 0, 0. That is where the vertex occurs. And something else that occurs there is our axis of symmetry, because you can see that the quadratic is the same on the left-hand side of that point as it is on the right. If you were to flip it over the y-axis, it would overlap itself. It's symmetrical there. So the parent graph of a quadratic has an axis of symmetry at x equals 0. We're going to use the x-axis number of where that occurs to state that. We can see that the parent graph it has a change of direction. It has a minimum at 0, 0, reaches its lowest point. So that is where our intervals of increase and decrease would be determined. We can see from left to right that it's moving down first and then changing direction and back up. So if we stated these intervals, we would say that our quadratic is decreasing everywhere to the left of 0, and I'll show you how to state that, and it's increasing everywhere to the right of 0. Our domain and range, the other terms that we discussed, we talked about that every quadratic will have a domain covering all real numbers. In the x direction, it's going to cover all real numbers. But the range here, we can only see part of our picture starting at 0 and then above that. So our range, we would have to say, is from y greater than 0. All the y values greater than 0. Alright, so here are all the things we talked about, all the characteristics, and you can see how to state them using math notation. Notice if you're talking about something that is in your x direction, you're going to be using the x variable. And if you're talking about something in the y direction, you're going to use your y variable. So things that use the x numbers are going to be our intervals of increase and decrease, moving from left to right. We want to use x. When we state the range, we're going to use y. And when we state axis of symmetry, if we have a vertical parabola like this one, we will use x because it's a line occurring that goes through the x-axis. And then our minimum and our vertex, we'll just name the location where that occurs. Alright, so how do we know if our quadratic has been translated? Well, we're going to look at the equation or the graph. If we can see the equation, we're going to look in a couple of places. If we see that a value has been added or subtracted inside the parentheses of vertex form with our x, that's going to cause a horizontal movement. And actually, if it's a plus, if it's adding a number, it's going to move left, and if it's subtracting a number, it's going to move it right. That amount of units. So we're going to look at that a number there. If we see that our quadratic has had a number added or subtracted on the outside away from the x squared operation, that's going to cause a vertical translation, meaning up or down. And if we see that a number's been added, that means up, and subtracted means down. Alright, so we have here a translated parabola. So let's see what's happening and how it affects our characteristics. We're going to take a look, and we can see a very important part of this parabola is located at the vertex, which is here. That's the place where our direction changes. So -3, -4 is going to determine a lot of our answers here. So what would our equation be? Let's go ahead and fill that in. Let's use vertex form since we can see the vertex. Vertex form is y equals a times x minus h squared plus k. So if we fill that in with our h and k value, which is -3 and -4 at the vertex, that would look like this. Y equals x plus 3. I'm going to have a plus 3 because I'm saying minus -3. Okay, x minus h. And then plus k. Well, I'm adding a -4. That's my k. So I'm going to say minus 4. So I'm just filling in my h and my k, and it's kind of tricky with the signs, but we just have to make sure we follow the format of vertex form. Alright, axis of symmetry, the center of our quadratic, right here. Remember, we're going to use the x number to state that. So the x value that occurs is at -3. So we're going to say x equals -3 is this line right here that I've just drawn, the center of my quadratic. Alright, domain, we don't have to guess. We know that's all reals every time. So you can actually say all reals. You can write that out. Or you can do something like this, an interval notation, meaning everything from -infinity to +infinity. Okay, range. Our range is affected a little bit because we have moved off of 0, 0. We're now at -3, -4. And remember, range is an up or down characteristic, so we're going to use the y value there, which is -4. Our parabola occurs everywhere above -4. So think about that. When you're saying it, all the values above -4, how would you state that? You would say all of the y values greater than -4. All right, minimum, that's going to be where our vertex is located. So this quadratic has a minimum at the point -3, -4. You can list the coordinate or you can state the y value since minimum and maximum are dealing with the y direction. Interval of decrease. All right, so we're going to read this like a book and we're going to move from left to right. We can see first of all it's decreasing and then at -3 it changes and it begins to increase again. So our interval of decrease is everything to the left of -3. So we're going to use all x values less than -3. And then the increase should be the opposite. So everything to the right of -3. So there is all of our characteristics for our quadratic and our equation in vertex form. Now let's say that we are given a picture and it's a quadratic that's had some translations and we need to write the equation from that picture. All right, let's use vertex form again to be consistent. And it's very easy to do when you can see the vertex because all you need to do is fill in your x and y value of your vertex to this equation where you see h and k. So if we know the vertex to be located here, if we can see that at 2, -4, or if they give that to us, that information, what we're going to do is we're going to say, okay, x is 2, k is -4, and we're just simply going to fill it in. And we're going to assume this quadratic has no stretching or shrinking for the moment. We're just dealing with our vertical and horizontal translations. So to fill that in, that's all we'll worry about for now. We will fill in x minus our h plus our k, and remember our k is negative again. So instead of saying plus -4, I'll go ahead and simplify with those signs and say -4. All right, so take a look at that because that is our equation for the graph shown. So this concludes our lesson on translating the graph of f of x equals x squared.